Okay, so today we are going to do scalable design rules for the CMOS technology. So the scalable design rules are the rules that you need to comply to when drawing any layout in CMOS technology. So the important factors is in the beginning the minimum line width. The minimum line width is also known as true lambda. And this is used usually to describe the minimum size of the transistors that can be used in the design. So for example, in 1978, if the technology has lambda of 1.5 micron, this means that the minimum size of the transistor is 3 micron. Okay, and if as the time progresses, in 2004, lambda is reduced to 45 nanometers. So this way that the minimum line width is 90 nanometers. So what am I talking about the line width? It is in the transistor. So for example, your transistor is diffusion and the polysilicon in the middle. So the minimum line width is this size, which is 2 lambda. Okay, so let's look at how lambda is used. Lambda is used in the design. So here, in order to look at this design, you need to rotate. So this is your transistor, this is the transistor, this is diffusion, and this is poly. So the area where they overlap here is the transistor. So if you have the source and drain, they will be over here. This will be the source and the drain. Okay, so the minimum size is L here. This is also the one that we define as 2 lambda. So if the technology is 45 nanometer, this 2 lambda here will be 90 nanometer. Okay, and then they also specify the design rules. So for example, this polysilicon must be overlapped, must be longer than the diffusion. You cannot draw the polysilicon only until here. You have to make it longer. So the overhang, this is called the overhang, must be 2 lambda. So 2 lambda means 2 times 45 should be 90 nanometer longer than the overlap. Okay, so it must be 2 nanometer here, 2 nanometer on the left. This is the minimum size. Of course, it can be longer. Okay, now the diffusion. After, in order to form the transistor, if this is the source and this is the drain, in order to fit the contact, this diffusion, this green guy, should be at least 3 lambda. So 3 lambda, 45 times 3, times 3 is 15, 12, 13, 135 nanometers. Okay, and you have to put the transistors in a well, and the boundary of the well should be 5 lambda. So 5 times 45 nanometers. So all the dimensions are specified in terms of lambda. Why do they specify in terms of lambda? It is they do this so that they can use the same design if they shrink the technology. So let's say maybe 5 years later, they have an even smaller technology, for example 9 nanometer technology. So this design can still be used, but they just change the technology. So they shrink the device. So this one, this 2 lambda will now be 18 nanometer instead of 90 nanometer. Okay, so everything can be shrunk according to the technology size.